All right. So, hi everyone. Welcome to the session on Excel to Fabric and back again. So, we're going to cover three main things today. We're going to start with setting the scene. We're going to look at the context for this session by looking at the journey of self-service analytics. We'll then look at a case study. So, we'll look at a credit risk financial model in Excel, which starts in Excel, and we'll move this to a solution in Power BI and Fabric. And lastly, we'll look at some top tips for navigating that journey. So I like to keep things interactive. So before we start, we're going to do a little bit of a poll and just put some answers in the chat, and we'll see it here. One of the biggest challenges I think with Microsoft Fabric is trying to explain to someone, right, especially someone who doesn't work in data technology, those self-taught business users, as Sue was referring to, what is Fabric and why is it valuable to an organization? So, articulating a value proposition. So, some answers in the chat. Your CFO stops you in the corridor and asks you what Fabric is. What's the responses? What would people say? And I've got some hilarious ones to share that I did when I did this in FabCon. What people submitted, I did this a Slido poll, and it was just some of the things people said were absolutely hilarious. I'll see if I can put it up actually whilst people are Power BI plus plus. Yeah, plus plus. Quilted plus. Okay. Yeah.
I like that quilting
Nothing,
class.
quilting class. Nothing on lake houses or yeah, okay. Right. Whilst you're doing that, then let me pull up the answers that people gave. Power BI on steroids. Yeah, absolutely.
Mm.
So, all right. Let's see what we got. Okay, so let's see what we did, and this is what people said at FabCon. So, tool, architecture behind your success, fundamentals. I like this one. I pretend like I have to pee, so I rush to the bathroom, ask ChatGPT what it is, run back out and shout my answer, then get fired. Um, big tech stack. There's lots and lots of answers. Cloud based. The one friend you have that you know is a genius, but you don't understand what he's doing, but you trust him. It's more AI than Fabric, I think, on that one. But yeah, absolutely. It will predict the next global financial crash. Maybe it will. Maybe that's what Fabric and AI is going to do. It's going to tell us when we're all going to feel the next recession. But okay, so I'm going to start with a quick 2-minute kind of video. Have you
Hi,
sound?
I'm Michael.
Can you hear that? Is that coming through? I'll play it.
The CTO at PPF Corporation. Like many large
Cool.
organizations, we have a whole raft of data sources, pipelines, and reporting requirements. It's a complex estate. We've rolled out Power BI and are looking at introducing Microsoft Fabric. If we get the self-service model right, this should reduce the dependency on my team. But I put forward a budget proposal to the CFO to purchase Fabric, and let's just say I got a bit of pushback. Have a watch of this meeting and you'll see what I mean.
Hi, Michael. Thanks for meeting me. I've had a request through from IT to purchase several Microsoft Fabric capacities, and I'd like to understand a bit about what it is, please.
Yes, of course. Fabric is the next evolution of Power BI, incorporating not just visualization, semantic models, and self-serve ETL with Power Query, but a whole raft of software as a service data platform tools that can be spun up in minutes rather than days or weeks of data engineering effort.
I don't understand any of those technical phrases you used, but it sounds like you just want some fancy new toys for the IT department. We've already spent so much on Power BI Pro, Azure, and Databricks. It all does the same thing. I don't see why we need it, and we just haven't got the budget.
No, it's not just tools for my team. It's for all of our colleagues to work with data more effectively, including your team. You can finally move all those clunky finance Excel spreadsheets into something more scalable, governed, and automated.
Personally, I think it's just the tools being overhyped and not living up to their promise, just like Gen AI today. I'm not denying that they're not powerful, but frankly, Excel always trumps any specialist software tool. It's powerful, but also has the flexibility to do whatever my team need with the data.
Yes, and that flexibility is a double-edged sword. It's great that your analysts know how to use it well enough to build their custom processes with it, but an Excel spreadsheet just doesn't scale to large data sets. You end up with multiple versions of the truth, and there is no row-level security or even proper access control built into it. So trying to apply any governance is a non-starter.
Yes, we've been picked up on audits a few times now where we're unable to provide an audit trail of access or to explain how and why formula logic has changed. I still don't see how Fabric will help any of this, though, or that I can convince my team to give up the flexibility of Excel.
I can see that it takes a lot of getting used to, but the lack of flexibility in Power BI and Fabric isn't a bug, it's a feature. The best way to understand this is the mantra Microsoft used as an objective for self-service business intelligence. Discipline at the core, flexibility at the edge. What this means is that in order for reporting and analytics to be valuable, it has to be trusted. And without a certain level of lineage, security control, structure, and repeatable automation and logic. That is the discipline at the core. Then trust can be easily lost in the data.
Yes, that is my mantra and my key objective for our finance strategy, to build trust in our finance data. How does Power BI and Fabric achieve this, though?
Okay, so yeah, hopefully there's some food for thought there. And I think that mantra, discipline at the core, flexibility at the edge, really sums up the real value proposition of Fabric. So, and Power BI. But so how does it do this? How does it achieve this discipline at core? The first is we've got the separation of inputs, logic, and reporting layers. With Power BI and Fabric, you have things like data transformation logic, semantic models, and visual reports. And they're all separate artifacts that can be managed and secured separately, complete with version control, Sue's going to show with Matthias, and audit access trails. You've then got data managed centrally in a data lake. So all your data and logic is stored in a data lake where it could be secured and governed. It can connect directly to source systems, and of course can be connected into tools like Purview. And thirdly, we have automation and process standardization. So along with time saving, one of the key benefits of automation, whether that's Power Query or notebooks, is that it helps to standardize the process. Because when you automate something, it's done in the same way each period. And when you include data validation as part of this, it ensures that those steps aren't missed out due to the inevitable time pressure that finance teams have and other teams involved in doing some of that work manually. So that's discipline at the core. Then let's have a look at flexibility at the edge. So this is the flexibility to allow non-data engineers to be able to combine, clean, and transform data at this edge using tools like Power BI, data flows, data wrangler, pipelines. We have secure sharing, data report sharing. So the fact that Power BI and Fabric are closely linked into Entra is, I think, one of the reasons it's dominated the market. And so being able to set row level and object level security at a semantic model or lakehouse level is a massive benefit here. And thirdly, we have data visualization and Copilot. So Power BI provides that flexibility for business users to tell the story with their data and take their stakeholders on a journey of data discovery. So Copilot is obviously a massive draw for Power BI, and the whole process of shaping, transforming, and modeling your data in Fabric helps to add the right context that Gen AI needs in order to give useful results. So that's what Joshua was saying, and I've introduced the AI avatars before an intro to myself, but here you can see that I kind of been on both ends of that journey. The first half of my career started doing tax technology consulting at Deloitte, financial control, HSBC, process automation at Barclays, and financial modeling at KPMG. And then the second half is involved me working for Avanade, which is a joint venture between Accenture and Microsoft. It's actually the largest Microsoft-focused consultancy globally. I think it's been partner of the year for about 20 to 25 years it's been around. And obviously I fell in love with the world of data, with Power BI, with Fabric. And that's like, so I'm an MVP, and I came an MVP in 2020. And that's that passion that keeps me going. It's that thirst for learning, it's for sharing knowledge, for edtech, for innovating, and how we make these tools easier to learn and apply. So I want to spend a little bit of time actually just going through the credit risk model in Excel. This is really important because I think to understand how we bring something into Power BI and Fabric, we need to firstly really understand the data and the logic and the process that we're building in Excel. So I'm going to be, for a series of kind of videos, because there's lots of things going on here, and I kind of want to be able to talk through these things as I show them, rather than trying to switch between so many screens. So here, we've got an Excel credit risk model. So this model assesses the credit worthiness of countries, sovereign nations, in a similar fashion to like we do with individuals. So we look at economic metrics like income and debt, as well as the broader political and institutional environment. We combine all these factors to give us scores, which we sum up to get an overall credit score and rating. So the rating is based on these 4 factors: economic strength, institutions, fiscal strength, and susceptibility to event risk. We use a scorecard-based approach to calculate the credit rating. So each factor contains a number of metrics. We come up with a standardized metric score for each one, and then an overall score for each factor. This sheet shows the metrics underneath each factor. Some of these are economic factors, things like Fitch rating factors, which we get things like GDP growth or levels of government debt. Some of the institutional metrics are value score provided by the World Bank, and some of these factors are analyst input driven. So we have a value between -3 and 3 to reflect the analyst views on the domestic, political, and geopolitical risk. For the economic data, we've got a spreadsheet for each country. So here we can see all the different categories. And now if we look at an actual spreadsheet for economic data, so this is one for the UK, where we've got metrics under each category, like domestic economy or public finances. And so we can copy and paste these values from each spreadsheet for each country into the tab with the same name in our Excel model. So we have an Excel model that's got a sheet for demographic society, and we can see here we've got UK, then underneath we've got Italy. So we have all the countries' data copied underneath each other, and we've added a column there on the left for a concatenation field to help with our lookup. So the UK, the country, and the metric, and then we can look up against the year on the columns. So for World Bank data, we just have a single table here with a metric value for each country and each year over the past 30 to 40 years. And then for the analyst input, if we look at that next, here we have an Excel spreadsheet containing 3 scenarios. So we have base case, bad case, and worst case. And for each of these scenarios, we have a row for the analyst input values for each country and year. So this is looking at base case for Australia. So for each year, we can see who it's input by, and we can see the values between -3 and 3 for those adjustment factors. And these are all the columns here into the right. So that's our data. Let's now look at how the credit ratings are calculated. So the user selects here in the drop downs a country and a year and a scenario, and they can view the credit rating calculations for that. So we choose, say, UK, year 2024, and the base case scenario for the analyst inputs. Underneath, we have a scorecard metrics, and then we have formulas in the right to extract out the metric values and score them. So looking at the formula here for real GDP growth, we can see it's index match against domestic economy sheet. So that was one of the Fitch economic sheets that we have there against that country and against that year. For ones relating to World Bank, we can see we look up against the World Bank sheet, the World Bank government indicators. And for the analyst input, it's an external workbook. So the analysts put it into a separate scenario sheet, and we look up against that. We then want to score this metric against a standardized scale that applies for any country. So these are the rating scales that we use for that. So we can see how the metric values map on to a numerical score. So if we take, say, real GDP growth, the value of 0.91% for the UK in 2024, it maps to a score of 5 and a metric rating of B3. This numerical score is then returned here in column L on the scorecard, and the metric score is calculated as that score multiplied by the metric weight, which you can see there in column E. The metric weight, 25%, times 5 is 1.25. So then all the metric scores are added up, and then we add in all the analyst input values, the -3 to 3 adjustments, and we get an overall total for each factor, for economic strength, for institutions, and so on. And then we have here a weighted factor score. So now we have 4 weighted factor scores in column I there, 4.39 and 3, For institutions, 4.19 for fiscal strength, 3.5 for susceptibility to event risk. So we've got 4.39, which is just the sum of all of those scores. We've got 3, we've got 4.19, and we've got 3.5. So then we sum up all of those factor scores, overall factor scores, and that gives us a numerical rating overall of 15. And then we look up that value against our credit rating scale, and we can see that 15 maps to an overall credit rating for the UK for 2024 base case of A2. Any questions on that? I know that's quite a lot to go through in there. There's a lot in that Excel model. But I wanted to kind of go through the logic. No questions. No. Okay. But anyway, so let's now look at that. That's our starting point there. We've got that Excel solution. So whilst our Excel solution provided a good functional starting point, the user feedback, that hypothetical user feedback that we have on this Excel model highlights some of these limitations of working with this credit risk model in Excel. So we have a limited range of countries, and each time we want to add a new country, we have to go and download the data and then copy and paste that data, get the concatenations, make sure the lookups are working. And it's a bit of a manual and somewhat clunky process, I think, to add a new country or year. And that creates a bottleneck on the individual or the team that are responsible for updating this model. We don't have any ability to compare countries or scenarios simultaneously, where the user has to make individual selections through those drop-down menus. And that limits the kind of insights they can get, and it forces them into inefficient workflows. It's difficult to follow the logic. I mean, even that quick run through, we had to try and follow through that flow from the different sheets and how they're connecting together. And I think that can make it quite challenging for people, especially if they're new to this and they're not hugely familiar with credit risk ratings. And the lack of visualization, and here we didn't even have conditional formatting and stuff. It means that users really struggle to identify patterns and trends in that data. And then also we have that external link. So the analyst input sheet was an external Excel spreadsheet that people update. And just having external links, I think you've worked with external links before, right, in Excel, Sue, and it could be a bit of a nightmare, right? It creates this technical debt. So, the feedback here is that, this causes the model to break, which undermines its reliability. So whilst the Excel model serves its purpose that it was intended for, I think there's a need for something more robust and something more user-friendly that can better serve the analytical needs of the users. So when we start now, if you looked at any of my community sessions in the past, I always start Power BI solutions with a scoping template. So this is like a simple Word document that prevents reports from just trying to be all things to all people and end up not serving anyone. So the first thing we do is we need to understand our specific audience and their problems. So here we've got a credit analyst, John, who needs global credit rating distribution, the economic metrics. And then we define the business questions that they want each report section to answer. And what's important to capture in these questions is how they'll evaluate performance and use the insights. How will they know if a number presented on the report is good or bad? And what will they do with that information? John is interested in looking at countries that perhaps have the same rating, but quite different economies, or vice versa, to understand how the credit ratings are driven by economic factors, say in the base case scenario. Once we've established this, we list out the key KPIs and measures that will help us to answer those questions, and what we would need to slice and dice by in order to be able to answer them. So we don't need to define the exact measures here. We have a separate template for that, but we do need to highlight this combination of numerical calculations and attributes that we need. So things like credit ratings and economic metrics, sliced by country, year, scenario, and country type. And then finally, we identify the data sources to support these calculations and attributes. For other areas of analysis, John wants to be able to directly compare any two countries and understand how the ratings are calculated for each under different scenarios of analyst input. And for a given country and year, he wants to be able to compare the impact of different analyst inputs. To what extent do these different forecast scenarios and judgments actually impact the overall rating in that year? And of course, he wants to be able to actually go in and add a scenario in a way that's at least as easy as typing values into an Excel spreadsheet. And if you covered this before in some of the sessions you've had, like writeback or adding scenarios and adding values in before, Sue?
Yeah, Yeah, some
Yeah.
of them have been
Power
covered.
ups.
Yes, power ups we've had.
Yeah.
Yeah.
And historically, that's not so straightforward, right? And especially with licensing and things like that with power ups. But there are some newer features that we're going to look at here. Yeah,
Translitical as
translitical.
well.
Yeah, exactly. Jake said translitical. So that's what we're going to look at here as well. How do we do scenario modeling where we can write back a solution with translitical task flows? So let's now look at how the Power BI and Fabric solution helps to deliver those insights from the scoping template and address some of those pain points from this current Excel solution. And as we go through this, remember that the goal of data visualization is to reduce cognitive load. So to make it easy for people to evaluate performance and understand what is driving the numbers. So here in the country overview section, our credit analyst, John, he wanted to be able to see at a glance the spread of credit ratings across the globe for a given year with base case assumptions. And we've got this great map, which is the natural way for us to communicate that. With this is, do you know what this is, Sue? This, does anyone else know what map visual this is?
Or James Dale's
exactly.
icon map.
Icon map. So icon map from Tacantes. Yeah, it's not the best example of icon map, but map visuals have not been my thing, even though I worked for James for so many years. But you can see all the different countries here colored by credit rating, and we've got the same colors against each rating used in the bar chart and in the scatter plot. And so we can see at a glance how many countries have each rating, and then you click on a bar chart element and it filters the rest of the visuals, so we can see what those countries are with that rating. We hover over a country and it shows some key metrics for that country and an overview of their credit ratings over time. So the next thing John wanted was to be able to look at specific types of countries. So comparing ratings across countries of a similar size or debt levels, perhaps. So we can do this using the measure slicers we've got there at the top. So we can filter down countries by, say, population or debt percentage of GDP. And we can also compare countries against any two economic metrics in the scatter chart. So here in the scatter chart, we've got unemployment and liquidity ratio, but we're using field parameters here to be able to choose any two metrics we want to see, one on the x-axis, one on the y-axis. And so here we can see, say, US and UK, they have the same overall credit rating in 2025 and actually the same unemployment rate, almost exactly the same unemployment rate. But the liquidity ratio, so the ability to meet its short-term financial obligations, is half the value in the US compared to the UK. So if I have a choice to lend to either economy, maybe the bond interest rate is similar for both, how can I compare these two to see what's driving the ratings for them? So that's the next thing John wanted to see. So we can do a country comparison. So we can select a country, say US, and now we have this drill through button enabled, and we can drill through to the country comparison. So now we say we have US and we can select UK as the comparison country. And again, we're focused here on the base case scenario, but we could look at others. And we can see that whilst the total weighted score is similar, so 15 for both in 2025, the makeup is quite different. The UK scores higher on economic strength, on fiscal strength, and slightly higher in institutions, whereas the US is much higher on susceptibility to event risk, right? They've got lots of funds to bail out banks and big tech if all these events happen. So if we click on a particular factor, say fiscal strength, we can see how this is made up from the individual metric scores. So we can see the UK has a much higher score on the level of government debt, a level of interest payments, for example, as a percentage of revenue. So we look at this both as tables and also as visuals. So with the visuals, we have an extra set of slicers here to narrow down the lines. Otherwise, you just see too many lines on the chart. So now we're looking at overall factors and the metrics that make up those factors and how they rate over time. So we've got now our country comparison. So now let's look at scenarios and let's look at how those factor and metric scores are impacted by analyst inputs. So here we can select a country, say US, and how the difference with the three scenarios that we have, bad case, base case, worst case. So we've got A2, and to give you an idea, that relates to a numerical score of 15. BAA2 relates to a score of 12, and BA2 relates to a score of 9. So there's actually quite a big impact on these analyst input adjustments on the overall ratings. In the other visuals, we can see how the analyst input variable values differ under those various scenarios. So for fiscal strength, the overall factor score is 1. in the worst case, 2 in the bad case, and 3 in the base case. And then if we click on any of those, we could then see the individual analyst inputs for US in 2025 under each scenario. So here now we're starting to look at a few different lenses of what's impacting our overall ratings and what's making that up. Is it scenarios and things like that? So historically, that's been about as far as you can go with Power BI. It's great for comparisons and analytics of the data set. But if you wanted to add your own scenario, you'd be stuck, or you'd have power apps or something like that. As I said, it comes with its own challenges. So what we can actually do with, let me see if I've got this translitical task list slide. I'll try and put it up actually. I think I've missing a slide from here. But what we can do with translitical task flows is add an action to a button in Power BI, which takes those measure values, and it could be those user input selections, and call a user-defined function in Fabric to be able to write back, say, to a SQL database that can in turn be one of the sources for the report. So let's say I'll come back to that in a minute. Yeah, so let's go through first how we now think about taking this value into Power BI, how we take the solution, into Power BI. So yeah, just bear in a second. I will bring up the translitical task loads one as well in a minute. So actually, let's have a look in here. Let's see what we've got in here. So if I look in here, I think I've got some stuff in here on. Maybe a second. Here you go. Yeah. So this is the translitical task loads, right? So I did have it afterwards. I stopped that video too early. So yeah, we've got here translitical task flows. So what we can do with translitical task flows is we can go in and take that write back capability. So we add an action to a button. So we've got here our slicer values, and we'll have a look at this again in Power BI. Takes those measure values. So we take the parameter sliders, we have text boxes, we call a user-defined function in Fabric. So this is what writes back to, say, a SQL database. And then that SQL database is updated with these new scenario values. And that database is then used as the source in the Power BI report. So that's where you get the loop back. So let me just play this again and we'll see where that goes. So yeah, this is the example then of the scenario manager. So now here we can see we're adding analyst inputs for given country. So we've got USA 2025. We'll make this a bit of a mixed scenario. So some values are 0 and neutral, some are -3, some are +3. We give this a name. So Rishi's view of the US, and we add any comments. So we're saying here, reflecting the current political situation in the US and across the globe. We click on add scenario. It's not instant. It took a few minutes in reality. We get a message saying that's been run successfully. So now we can see the database in Management Studio connected to the Fabric SQL database, and we run a select query, and we can see here the scenario. So my Rishi's view of the US 2025 input by me on the date, and these are the input values. So those were just username functions, today functions in DAX. So now we could bring our scenarios directly into Power BI for a direct query connection, and we'd see that reflected straight away. But actually in our situation, our scenarios are actually baked in to fact and dimension tables. So we need to regenerate these tables before they appear in our model. So we actually have a direct lake model here. So we don't actually need to refresh the semantic model, but we need to rehydrate those silver and gold lake houses based on those bronze inputs. So those bronze inputs are our bronze lakehouse tables, and also this Fabric SQL database with the analyst inputs. So we're going to go back in here. We can see the lakehouse. We're going to run a pipeline. So we click on the pipeline and we click on run. And this is going to kick off the data flows to bring in the data, including the scenario inputs. And then now we go back to the Power BI report. We go to the scenario comparison tab, and we can see there now we've got Rishi's view of the US. So we only have one for 2025 at the moment. We only did it for 1 year, but we can start to see those values now feed in. So this is now feeding into our scenario analysis. And then actually, before we leave the Power BI report, one of the reasons we also wanted to bring this into Power BI was to take advantage of Copilot. So in the app, we click on the Copilot button and we ask some questions. So firstly, we just ask it to explain the report, and it gives us, let's see what it says, so explain this report. And actually, I think this will be different now. I think it's, I've tried Copilot more recently and it gives you some different answers, but it's given you a fairly detailed explanation here, not just of what the report shows, but some specific insights. It's giving you the average metric values across the countries. It tells us that unemployment varied from 4% to 15.9%. And it gives us an overview of the impact of the various analyst inputs. So now we ask, then the next question that's been answered here is, what economic metrics are the biggest drivers of the credit ratings in 2025? And for some reason, it's focused purely on US. It seems like everything Microsoft just focuses on US by default. But anyway, it gives us the metric scores for that. So now we're asking something more challenging. We say, well, how does the UK and US compare on these key metrics? Because they have the same credit rating overall, but obviously quite different economies. So I'm giving it a bit more context than what I want it to focus on. And now it gives us the metric scores under each of those different categories and it compares them. And I think lastly, we want to make this actionable, right? So we want to say, okay, I'm an investor. What does this mean for my investment strategy? What's the real world implication of these differences? If I'm making a decision between investing on UK or US Treasury bonds, what should I be considering? And the idea here now is Copilot's intelligent enough to really understand what these metrics are measuring, and what that means for a bond investor. So it's giving me some really interesting insights here because it's interpreting these measures. It's not just telling me what they are and what the values are. It's actually telling me what that means for how the country's economy is performing. So it recognizes that we've got a high score on governance and institutional quality, and this enhances investor confidence in rule of law and contract enforcement. And it gives me some of these investment considerations, so some considerations for my investment decision. I did go a bit further and ask it to give me suggestions for my analyst inputs based on the current economic and geopolitical environment. And it didn't really like talking about politics, Copilot, but it did tell me some economic factors that I should consider when I'm setting them. So please provide suggestions here. And it's saying, suggest using a moderate growth rate for the US, reflecting persistent inflation, tighter monetary policy, and global economic uncertainty. So I think now let's look at how the solution was built in Power BI and Fabric. And what I want to really focus on here is the thought process and the overall methodology. So the first thing we might want to consider here is actually refactoring our Excel model so that the metric and score lookups are all referring to a single sheet that has all of our data values and calculations. So rather than trying to look across all these multiple sheets, we want to combine it all. And so this is going to give us consistency in our approach. So this is actually not really Power BI and Fabric. It's more thinking about data in a different way and thinking about financial modeling best practices. So we have our data structure also closer to what we would need in Power BI or Fabric. So, we had one of the feedbacks in that hypothetical feedback that the scorecard works for this very narrow use case of being able to select a country, year, and scenario and see how the credit rating is calculated, but you can't really compare time periods or countries. So we have to click on each individual drop down and remember those scores or write them down. We can't really graph the results this way or put them into a pivot table because the outputs are all driven by these input cells. So what we need to do first is have a table with all the combinations of countries, years, and scenarios. And then we have lookups to extract out the metric values and the metric rating scores for that row, for each combination that we have here. So if we just do that here, so now we can see here where I'm using the unique function and filter functions to be able to get those unique combinations of all of those. And actually Power Query would have been a much better way to do this. But here I've used dynamic arrays and lambdas to try and do essentially the same thing to get all the unique combinations of countries, of years, and scenarios. So I'm using a lambda here called out to join which I think I just got from the internet. And so here we can see then all of those country contact metrics, the metric value. And yeah, I haven't gone all the way with this, but you can kind of see the concatenations and the lookups. Yeah, so this allows us to then have consistent formulas in our scorecard. So then all it needs to do.
What was the speed like?
Yeah.
What was the
Sorry,
speed like, Rishi?
I mean, there's not that much data in here. Right? I think it's about 2,000 rows in total. Yeah. So it's not necessarily a performance issue. And I think a lot of the cases you work with Excel, it's not necessarily about I've got too much data. I think it's about the structure of that data. Yeah. So bringing everything into one table allows us to have one consistent place to look up.
Just curious, what made you go for dynamic arrays and lambdas as opposed to Power Query?
Because I just wanted to do it in native Excel. Because we're going to go into Power Query next. Right, we're going to look at how we would do all of this in Power Query. And I think with Power Query, it's less about just combining data. We need to also think about where we're going to introduce the logic and do all of that stuff in there as well. Yeah, so that's why, right? So what we need to think about now for Power Query, so now our first step was to think about our data as one big table. The next step is to think about how to structure this into a star schema. So how do we get the facts and dimensions relating to these? And the facts and dimensions we need, we can really pick up from these, from the scoping template, right? So we have two columns here. We have KPIs and measures and view filter by. So obviously, you know, and everyone else here as well, that this is facts and dimensions, right? These are our facts that we need essentially, and these are the dimensions we need. We need a scenario dimension, a country dimension, a year dimension. And we can use this to design the kind of conceptual model that we end up with in Power BI. Right, so this is the model that we kind of end up with in Power BI. So we have 3 fact tables. So we have this first one is the lowest level of granularity. So the reason we have different fact tables is for different grains. So this is the lowest grain. So this is the fact table by scorecard by metric rating score. So this is basically similar to what we started building in Excel. So this is what I'm saying. This is, yes, it's one fact table that we need to build with those. So we have the metric values, we have the corresponding scores, and we have the metric rating label for each combination of year, country, scenario, factor, and metric. We then have our second level, which is scorecard by factor. And this is actually a more aggregated one. So this is an aggregation of that first fact table grouped by factor. So now for each factor, it contains the sum of the metric scores multiplied by that weighting. So remember, we had 5 multiplied by 1.25, whatever, to give you a weighted factor score for each combination of factor, country, year, and scenario. So remember, we have metrics underneath factors. So now this is aggregated. And then the final fact table is again an aggregation. So now it's a grouping of that second fact table. So now we sum the weighted factor scores by country, year, and scenario to give you the overall credit rating score for each country in each year under each scenario. So that then gives you the blueprint for what we need in Power Query. So what we're doing now is thinking about where to store our files. So actually SharePoint is one of the most accessible places to store data, especially it's the source behind Teams. So we can upload files to a Teams channel. Once we then click on Open in SharePoint, we take the SharePoint URL, go into Power Query, copy that SharePoint URL in Power BI Desktop. So we create a new parameter here for that URL. We then go to SharePoint folder, and we say we want to, and that's what's behind Teams. Behind each Teams channel is SharePoint folder. And then we've used select parameter. So we say we want to connect into this SharePoint folder, create a new connection, we authenticate, and then, yeah, we can see all the data now in that Teams channel. And now we click on transform data. And now we need to combine data from all the countries from the Fitch economic files. Now, just using a combine feature, so this is all the underlying files that we looked at the beginning. So now we do it for each sheet. So now we're combining all the balance of payment sheets for each country, for Australia, Germany, Tunisia, and we go in here. So this is now Fitch economic files, but it's actually just balance of payments. So we now can duplicate that query and do this for another sheet and so on. So now we're doing domestic economy. So now we've got domestic economy, and we end up with loads of these transform functions and steps, and it actually gets quite messy. But this is the default way of using Power Query. But if we know just a little bit of M, there's a much more efficient way of doing this. So what we do now is we have our SharePoint files. So these are all our files in here. And we just add a custom column called excel.workbook, not excel.workbook, excel.workbook, pass in the content. And then when we expand this, it gives you a list of all the sheets in each workbook. And each sheet is in the same kind of format. So now we can just combine it all as one step. We don't need to do multiple combines for every single sheet and have, dozens of those functions and tables, all the things it creates. So now we can see now all the Power Query steps completed. So we've got extract queries. So those just connect into files and combine them. We then have transform queries, which create the initial structure for our fact and dimension tables. And then we have load, which has our final fact and dimension tables that we need. Once we brought it all into the semantic model, we need to create the relationships and measures. And I actually wanted to have a separate measure with the average value for each one of those 140 economic metrics. So I used a script here from the Tabular Editor, which just bulk creates all of those measures. So just by running those scripts, I now have all of those kinds of measures, all those 140 measures for every metric. Then we do visualization. And here on the overview page, we've got field parameters for the X and Y axes for the scatter plot. We have some card visuals, we have slicers, and of course, icon map. And so this is kind of what's made up of, I'm not going to go into building how you build all of this stuff. I'm assuming people here really know, but the way I've also got the consistent colors for those ratings is by having the color codes, the hex codes, as part of the ratings table. So it's kind of as metadata. So then you can use them in conditional formatting and things like that. So yeah, 140 measures for each metric because I wanted to have the metric, but I didn't want to create those manually. True is an optional parameter in excel.workbook. Yeah, promote headers. Okay, yeah, probably should have done that. Good shout. Okay, so now we look at Fabric. Okay, so now we've taken our Excel workbook, we've put it into a kind of structure initially in Excel to kind of think about, rather than having things split across multiple sheets. And we've looked at the structure we need in Power BI, and it's a little bit more complicated. We need to think about those facts and dimensions, and what levels of granularity do we need to calculate things at. And that's the model that we then ended up with. So now we've done it in Power BI. We've built a Power BI report. It's connected to files in Teams on SharePoint. So now we go into why Fabric, right? Why would we start to think about Fabric? Well, for a start, working with the files in SharePoint is really slow. I don't know if you've done it before, Sue, but it's just as soon as you start to get, beyond 10, 20 files, it really, really slows down. So when you start to
mine's not too bad. Yeah, not too bad actually.
Oh, really?
But then but I tend to then, if I'm doing too many, it'll go into a data flow. But not too much of an issue really.
But I mean, if we put them into a Fabric lakehouse, right, then it's much more efficient, because then we can convert them into Delta tables, and it has a SQL endpoint. And that
if you've got Fabric, I think, yes, obviously if you've got Fabric, that's great. But
yeah, and you have Fabric for $300 a month, right? That's an F2, right? So, or, if you have premium, obviously in Power BI, then you have Fabric automatically anyway, because they're all SKUs, right? So I think, for performance, I think is one reason we definitely want to start considering Fabric. We have this kind of medallion architecture here. So we have the data in bronze, silver, and gold layers, all as kind of separate lake houses that you can kind of access and secure separately. And maybe if you've got another process that doesn't need those gold layer fact and dimension tables, but it needs data from raw or from bronze or silver, then you can shortcut directly to those layers without creating another copy of the data, or without having to repeat those transformation steps separately in another process and another Power BI or another Power Query, and end up doing it differently or inconsistently. And we can actually apply lakehouse row level security to each of these lakehouses individually. So if someone's consuming data, say for only countries or metrics that they're allowed to see. And we also have obviously direct lake mode as well, right? So we don't need to, as soon as our lake houses are updated with data, that's instantly available in the Power BI report. So what I wanted to get across here is this really summarizes this whole thing that we started with, right? The discipline at core and the flexibility at the edge. You have your data here as central lake houses, you have row level security, object level security, even at the lake house level, and then you have things connected into it for the different purposes. So in terms of the methodology for the Fabric data flows, I'm going to show two approaches here, right? So the first one is data flows, as you're saying, and this is your way to kind of scale it. So here we've got a folder that contains our data flows, and we can see we've got 3 data flows, Excel to Bronze. That takes the Excel files, converts them into Delta tables in our Bronze layer. This basically has exactly the same queries that were in the extract folder in Power Query, right? So it just connects into data, into Excel files, into the files layer, puts them into the tables layer in a data flow, right? So we could actually copy and paste this Power Query queries from Power BI Desktop and change the connection from SharePoint, which was doing initially, and put them into Lakehouse instead, connected to Lakehouse. The second data flow that we've got is Bronze to Silver. So this takes those Bronze Lakehouse Delta tables as a source, applies some transformations and joins, and gives us our kind of conformed data. So that was the transform queries that we had. So this is like taking our Fitch data, our World Bank data, our analyst input data, getting them all into the same structure against a kind of standardized metric ID, say all of those transform queries that were in Power Query. And then we have a third data flow, Silver to Gold, which takes our conformed data and produces those final fact and dimension tables. So these were the queries that were in the load folder in Power Query. So that's how we're going from Power Query, Power BI, into data flows in Fabric that are loading to lake houses. So we have a look at one of the data flows here. So this is the extract query. So this is using one lake file sync. So there's a guy in a cube video there that shows that it connected to just using, you connect into the files layer. So you can just sync that from your machine and, bring it in there. And then that gets brought into the Bronze Lakehouse. You could also use shortcuts, like shortcut transforms will transform from CSV to Delta table automatically as new data gets in there. So we've got all the extract queries here. We combine all the data together. So like we were doing before in Power Query from the Fitch Excel files, and we output to the credit risk Bronze Lakehouse. And so from Bronze to Silver, so this is our second data flow. Here we use the Bronze Lakehouse as a source, and I've actually just done this as a function, right, to make it more efficient. So here we're seeing it's called, the create Lakehouse connection. So all I'm doing is passing in the table name, and it's taking that table from the Bronze Lakehouse. So we're standardizing that connection step. So we're bringing in multiple tables from the same source as separate queries. And then we've got our combine and join logic in here now. So now we've got we can see we're creating our Fitch, World Bank, analyst input data. Again, it's standardized with keys, right? So we've got standardized dimensions and facts where we're starting to bring all the metrics into a single table with a metric ID. And these output to the Silver. And then we have Silver to Gold. And this is then performing those joins. It's referencing the Silver tables for dimensions and outputting it to the Gold Lakehouse. And then with the Gold Lakehouse, we go to new semantic model, and we create a new semantic model now on top of our Gold Lakehouse. So rather than using this is actually using a one lake direct lake rather than the old SQL one as well, the SQL Analytics Delta one. So we choose the Delta tables in our Gold Lakehouse. We have a direct lake semantic model against here. And then finally, we open up this Power BI report. So this is an import mode model. This is based on those SharePoint files. So now to link this back into Fabric, we could go into here, into Power Query, delete all of the queries, and then just click close and apply. Now, all the visuals, of course, broken. So the only tables we have left are those DAX calculator tables, like our field parameters and things like that. So now we want to bring those tables back, and this time from Direct Lake, from the semantic model. So we just go to One Lake Catalog. We now choose Power BI semantic models and choose that semantic model that we just created in Fabric. And if all the table names or column names are exactly the same as we had in our import mode model, then this should just work. And we have the Power BI report that we had before, but now connected in direct lake mode into Fabric. So the other approach I was going to show, and it's up to you if you want to look at this now, or perhaps you haven't got time, but it was actually using a different approach to doing this ETL, right? Because data flows, I know there've been, some improvements in performance and things like that, but they do still have quite high consumption, and you can't really version control or standardize them in the same way you can with code, right? Like notebooks and things like that. So if you wanted to use SQL rather than Python, for example, to be able to do some of this ETL, what I was going to show here is kind of materialized lake views, right? So this is, this is something that's been announced. So these are views, which are just basically select queries that run dynamically. And so that, like, to Power BI, they just appear as normal views. So materialized views like cache those query results. So they create this kind of physical table-like performance. So if you just have a normal SQL view, you can connect into that in Power BI like it's a table, but then it will query that every time. Whereas with materialized views, it's basically like a Delta table that will just, I know, so you're a big Python fan, right? So, but I mean, SQL, a lot of people know SQL, right? So I think this is really useful for those kind of SQL queries that you can do. And I think you can, and I don't know, I haven't looked too much into Materialized Lake Views. I think I need to speak to Andy Cutler about it. But I think potentially what you can do here is link it to these kind of event-based triggers. So each time, the analyst input, gets updated. So someone adds in a new scenario, for example. Obviously we're doing it here through and the database gets updated through the translitical task flows, then it can incrementally update these lakehouse tables. So we don't need to go in and do a whole refresh of all of our data flows to bring that data in. As I said, we can't really do direct query against that because we need to bake the scenarios into these tables rather than just reference them directly. This is how you create materialized lake views, and you can actually also even kind of embed data validation rules. So we can actually put in quality, you can catch quality issues before they start breaking your pipelines or before those even reach your Power BI report. So I think there's a lot of power in some of these alternative kind of continuous flow ETL mechanisms rather than just a batch, data flows or notebooks and pipelines type mechanism. And yes, you see in the chat, a lot of people know SQL, so this is really helpful. And I think these materialized lake views are like, you had hybrid tables with Power BI, where you have a combination of those. So I think this is actually the materialized lake views that we have here. So all right, I think time to kind of finish up on this now. So just to finish up with some top tips for kind of migrating, if you like, from say Excel to Power BI and Fabric. And the first thing I want to highlight is that, have you seen this Forrester report, Sue? This economic impact of Power BI, and they've got one for Fabric as well. So I mean, you can just Google it, right? Like Forrester report. And it's, it claims that there's organizations, a composite organization, you achieved a 366% return on investment with Power BI. And, I think there's a lot of, benefits of doing that. So I think some of the tips to do this, I think we want to really think about not just the technology, but also people and process, right? And I've actually written all this up into a white paper, and these are the 5 steps I've written in this white paper on my website. So, firstly, define your North Star. Make sure you have a strategic objective for your analytics journey that guides every decision. So this could be, discipline at core, flexibility to the edge, and it could be that mantra that's going to guide you through that. The second is be obsessed with your customer. So Matthew Roach, right, Sue? So he recommended this book to me. I've got it here, the customer driven playbook. But you can't really see it here because it's grayed out. But what it says is that rather than trying to build a product and then try and find customers who want it, you focus relentlessly from the outset on understanding and meeting the needs of those customers and those end users. So you understand those Excel models, you understand why they're built, and you tailor those solutions using things like that scoping templates.
It's on my book as well.
Yeah, you've got it as well. Brilliant. Yeah. Have you read it? Yeah. It's a great book. So thirdly, we want to limit technical debt, right? So this is technical debt is kind of a disproportionate amount of time that you need to update and maintain a solution when you take shortcuts, or when you try to overcome those design limitations. So you really want to think about those best practices from the start and keeping things flexible and documenting things to make sure that the tools don't end up creating more work, like we saw with Power Query and things like that. We want to invest in skills, prioritize training and development. So make sure your teams have the expertise to leverage Power BI and Fabric. And you see this in organizations where skilled users drive much better adoption and results. And lastly, you want to build a data culture. So we need to foster the environment where data-driven decision-making is the norm. So this is where we encourage collaboration, trust in data, continuous learning. And this is really important when we're starting to think about moving to Power BI and Fabric. For Power BI Copilot, for example, we need that well-structured, curated data. So we need to identify those use cases. We need to understand the prompts that people are going to be asking. We need to understand the metadata and make sure that we enrich it with that. So this is a link to just learndatainsights.com or a QR code. And there's got a Power BI and Fabric readiness assessment. So you can answer like 10 short questions, and then you'll get a personalized score report. And you also get the link to download the white paper on that as well. So just again, with some bit more detail on kind of some of these things we need to think about when doing Power BI and Fabric. So yeah, sorry, I know that was a lot of content with all of those, but I think that's kind of, I did have the last bit, but it's fine, we're at the end of the session now, but essentially what this is showing is that, this is an example of an agent, a Gen AI solution that's taking the same credit risk model, right? So I did a recording of this session as a practice for FabCon. I uploaded that to Notebook LM and then asked it to basically give me the context for building an agent to do this work, to move from Excel to Power BI and Fabric. And we can actually see it's going and doing using chain of thought. So it's taking the Excel file, it's following this chain of thought through Claude's code, and it's reasoning through that process. So it's analyzing the structure and data patterns, it's identifying the rating methodology, generating a Power Query automation, generating a semantic model. We're going to see a lot more of this as we start to do AI, right? So it's identified some of those facts and dimensions, and it's actually asking the user for feedback as well to validate this. So, really powerful. It's working out some of that logic in there as well. And generating Power Query code, right? So I didn't use this to build a solution. The solution I went through is what I went through manually. But, I then worked with one of my friends to say, can we do this with AI? And, this is kind of what he came up with. And, definitely keen to explore this more.
Brilliant. Lovely. That's interesting. Thank you, Rishi. That was really interesting. Are there any last questions for Rishi before there's some clapping going on and some interesting Claude?
Claude is great.
Yeah. Any questions for Rishi before we sign off? Thank you, Rishi.
Yeah, I'll put the link to this in the chat as well, actually. So this is MCP server. So I think this is something that will be, it's in private preview at the moment, but going to public preview. So this really talks about a lot of those same things, right? How do we design spec and then build it in Power BI?
Yeah, we had a session last week all about AI and context engineering. So that was really interesting as well, just to understand. Just had to understand it. Jake's just seen he's seen a Reddit post and he thinks it's public now. So that's interesting.
Oh, really? Okay.
Yeah.
Well, yeah, it might be Ignites today, right? So yeah, possibly today.
Yeah. So yeah. And Pavel said it could be a security nightmare. Great session from Akash. MCP sound like they're already out of date. And you've blown to Kimi's mind.
I mean, it blew my
Oh, yeah,
mind
the new-
preparing for the session, even. So yeah, I know. I don't know. I think I need to cut it down. I think even for next time, but you know, to try and fit it
Yeah.
all in an hour is a lot.
Yeah. So yeah, Jake said, you know, it's more efficient to give it code to run so that you avoid the prompt bloat. But I think
Yeah,
it's like all of
absolutely.
these things, as we use it more and more often, we'll get more efficient at understanding how to use it. Oh, brilliant. Well done. Thank you, Rishi. It was
Thanks so much,
certainly
everyone. It's great
interesting to
to-
see. I mean, you're obviously very enterprise with the work that you do with Avanade. So
Yeah.
for you, everything is focused on Fabric. So it's quite interesting, you know.
Standardization and automation, right? All these big companies have all the same problems, right? They
Yeah,
have manual
but, I mean,
processes, they live in
yeah.
Excel. Like it's the same everywhere.
Yeah. Well, yeah. So lovely. Any last questions before I say goodbye and let you all go? So MCP not great. Anthrofox.
Interesting.
Who made
Interesting.
MCP?
It's the worker agents, right? It's an agent. It's not the whole solution. MCP
Yeah.
is the hands, right? That does the work, right?
Yeah.
The LLM is the brain that does the thinking. It's not just saying, well, you don't need hands because
Yeah.
you do. You need some way of doing it, right?
Yeah, definitely. Anyway, lovely. Thank you ever so much,
Thank you.
Rishi. Let me stop recording.
Thanks so much, everyone.
Great. Oh, thank you, Jake.